This is Pre-Calc, section 6.2, solution of linear systems in three variables. What we're looking at here will be equations that have three variables. We did systems of equations with two variables back in 6.1, but now we're talking about three variables, which means we're talking about planes in a three-dimensional space. And here's the kind of things that can happen with planes intersecting. You can have a single solution where these three planes intersect right there. Think about the corner of your room and think about the ceiling, the front wall, and the side wall, and where they intersect is that point of the corner. That's a single solution. You can also have points of a line in common. If you look at the way these planes intersect, you have this line right here in common. So all points that are on that line would be solutions to the system. And the third possibility is that these three planes are coincidental. They lie on top of each other, and therefore you have all points in common. Inconsistent systems may have no points in common like this, parallel planes. They have no points in common. Something like this, where two planes are parallel and the other plane intersects them, there's no points in common. No points in common here, and no points in common here. So we're going to look at some systems and solve them algebraically. So you want to start by eliminating the same variable from two pairs of equations. This can become a nightmare if you make a silly little sign or arithmetic mistake, or if you copy it wrong. So once you copy this on your paper, double check that you've copied it correctly, because one little sign boo-boo is going to make a big difference in your solution. So you want to start by eliminating the same variable from two pairs of equations. You can eliminate x, you can eliminate y, you can eliminate z, but whatever you choose to eliminate has got to go from two pairs of equations. I look at these two equations here and notice that the z's are opposite signs, so that if I add them together, the z's will cancel. So that makes a good choice for my first elimination. Add this up, gives me 3x plus 2y equals 4. So we've gotten down to one equation that has two variables. All I have to find now is another equation that has that same two variables. That's crucial. Same two variables. So since I used these two together to eliminate z, how about we use these two together to eliminate z? Again, you must eliminate the same variable twice. So I've chosen to do equation 1 with equation 2. So I'm just going to read. What I see is if I want to cancel the z's, I need to multiply this equation by 6, which gives me 12x plus 6y minus 6z equals 12. And I'm going to write the top equation just right next door, just copying it over so everything stays lined up, which minimizes the chance of making a silly mistake. So add these equations together. 3x plus 12x is 15x. 9y plus 6y is 15y. The z's cancel, and this gives me 15. Now, this equation right here can be divided by 15. It just makes sense to get the number smaller. So if I divide everything by 15, it's going to give me this equation, x plus y equals 1. So finally, we are down to two equations with the same two variables, and now we pick up like we did with section 1. To do this by elimination, I will multiply this by negative 3, which gives me negative 3x minus 3y equals negative 3. I'm going to rewrite the blue equation underneath. I know we could do it by just looking at it, but I think it's safer to do the rewriting. The x's cancel. This gives me negative y equals positive 1. And if negative y equals positive 1, that means positive y equals negative 1. Now, we chose to eliminate z mainly because these two right off the bat were opposites. You can get rid of whatever variable you want to start with, but you've got to get rid of the same variable twice. Now that I know that y is negative 1, I can plug it into this equation or this equation, whatever one seems easier. Well, this one right here seems easier. So this is x plus y, which is negative 1, equals 1. Add 1 to both sides, gives me x equals 2. Now I have two variables. I just have to plug into one of the original equations. I'll do this one because it's pretty easy. X is 2, y is negative 1, plus z equals 2. This gives me 1 plus z equals 2, or z equals 1, which means my ordered triple is 2, comma negative 1, comma 1. Remember, your order triple now has to be x, comma y, comma z, not what I found first, what I found second, what I found third. And then if you're smart, you will check this. And how you check is you plug 2, -1, 1 in for x, y, and z in all three equations. And this does check. You can stop the video and do the checking on your own if you want. For this one right here, I'm going to do just a teeny bit differently. On this one, I said we wanted to do z because it was obvious to see that these two canceled. But some people have a problem deciding what variable to eliminate. So here is what I call just a cookie cutter way to do this. And you could do this setup every single time. You could say, okay, I'm going to always eliminate x to begin with. So let's take these two together and eliminate x. To eliminate x, I'm going to multiply this through by -2 and this through by 5. And you might be saying, where did those come from? Well, all I'm doing is taking opposite. Take 2 up here, take 5 down here. The reason I had to make one of these negative is because I've got to have these cancel out, and the only way they will cancel out is if they have opposite signs. So multiply through by -2 gives me -10x minus 2y plus 6z equals +12. Be sure you're multiplying both sides by -2. This is now 10x plus 15y plus 5z equals 25. Add those up. X's are going to cancel because that's how we designed it. This is 13y plus 11z equals 37. So that is one of my equations that has two variables. Now I got to go get another one. And where I'm going to go to get the other one, I'm going to use these two equations right here and do the same process. But notice these already have opposite signs, which is great. So all I have to do is multiply this by 3 and this by 2. So this will be 6x plus 9y plus 3z equals 15. This is -6x minus 4y plus 8z equals 6. X's cancel out. This gives me 5y plus 11z equals 21. So here is my other equation that has the same two variables. Now before we finish the problem, let me just reiterate something. You can eliminate whatever variable you want. I just chose to show you what I call the cookie cutter version, which is to get rid of x both times, and then you're going to have two equations you can work with. So I'm going to bring this 5y up here. And this arithmetically worked out nice because I see these are both 11z. All I have to do is multiply by -1, which changes all those signs, which gives me 8y. The z's cancel out, equals 16. Divide by 8, so y is 2. And you can plug that y is 2 into either this one or this one, whatever one you feel is easier. I'm just going to go to this one because I've got more room here. 5 times 2 is 10, plus 11z is 21. Subtract 10 from both sides, gives me 11z is 11, so z equals 1. Now that I have two variables, I need to plug back into one of these, doesn't matter, and solve. I'll just do the first one because it's the first one. 5x plus y, which is 2, minus 3 times 1, which is -3, gives me -6. This gives me 5x minus 1 equals -6. Add 1 to both sides, gives me 5x is -5, so x is -1. So my order triple in x, y, z format is -1, comma 2, comma 1. It'd be a good idea to check, especially on a test. You may not want to check on all the problems you do homework-wise, but it's a good idea to check test-wise. There are a couple special case scenarios we need to look at, i.e. the no solution situation or the infinite point situation. So here's a system of equations. The only reason you know it's going to be a special case is because I titled this special cases. We look at this, it's the same thing as the last two. We have to decide about what variable do I want to cancel out. Do I need to do the cookie cutter or can I do it a little bit more easily? What I see right here is it'd be very easy to cancel out the y's. So I'm going to add these two equations together and I get x, the y's cancel, plus z equals 15. So that was pretty easy. I've come up with one equation that has eliminated y. I need to eliminate y again. And what I'd like to do is take this equation and this equation. And you might say, why would I do that? Well, the reason those two, well, the y's here already have opposite signs. So that just makes it a teeny bit easier. So multiply this by 3 because if I multiply all the way by 3, that'll make this a negative 3y, which will certainly cancel with that positive 3y. So negative 3x minus 3y plus 6z equals 15. I'm going to take the top equation and just rewrite it right here so that I don't make some silly arithmetic mistake. And I add these up, and the x's cancel, the y's cancel, the z's cancel, which gives me 0 over here, and this gives me 21. Remember, when you get a false statement, when your variables have disappeared, then this is no solution. Now, the only time you talk about something being false is if your variables have disappeared. There's x and y, z, they're all gone. 0 equals 21 is false. That is not a true statement, and therefore your answer is no solution, or you can use the empty set symbol. Now, would we get the same no solution conclusion had I eliminated something else to begin with? Absolutely, because there is no solution to this system. So it really doesn't matter what variable I chose to eliminate in the beginning. This is another special case because there are 3 variables, but there's only 2 equations. So this tells you over here, if the equations are dependent, write the solution in terms of the variable z. That is telling you that when you do this and you eliminate to begin with, don't eliminate z. Don't eliminate z. So you can eliminate x or you can eliminate y, whatever you want to do. So I'm going to multiply this by 2, which gives me 6x minus 2y minus 8z equals negative 18. I'm just going to rewrite the top equation right underneath it so I don't make a silly mistake. This gives me 7x, the y's cancel, minus 7z equals negative 14. I'm going to divide this whole thing by 7 because I just like the numbers to be smaller. So here I have x minus z equals negative 2. And here's where the problem comes in. I have no way to create another equation with these variables because I only had 2 equations to begin with. This tells me that this system is dependent. So I have x minus z equals negative 2. Go back to these directions. Write your solution in terms of the variable z. That means your solution will be something, comma, z. So we're going to write expressions using the variable z to stand in for x and y. Well, I can get x here very easily by adding z to both sides. So I have z minus 2. So z minus 2 goes right in here for x. What I have to do is use this and this to come up with an expression for y. So let's go into the top equation. So in place of x, I will put z minus 2. And of course, y is going to stay y for the moment, plus z equals 4. So z and z give me 2z. So this is 2z minus 2 plus 2y equals 4. I need to solve this expression for y, so everything else needs to move to the other side. So 2y staying here. Subtract 2z from both sides. Add 2 to both sides. So now I've got 2y equals negative 2z plus 6. Divide everything by 2, and my expression for y will be negative z plus 3. And that's what goes right here. So that is my solution in terms of z. I've got negative z plus 3. You could just as easily write 3 minus z. That doesn't matter. Now, what does this mean? That means these expressions will generate every single point that is a solution to this system. So let's pretend, let's say if z equals 0. If z equals 0, 0 minus 2 is negative 2. 0 plus 3 is 3. And of course, put 0 in for z, we get this. So negative 2, 3, 0 is a point that is a solution to this system. If z equals 1, if I put 1 in here, 1 minus 2 is negative 1. Negative 1 plus 3 is 2. And of course, z is 1. Those are just 2 of the points that are the solutions to this system. There are an infinite number of these points, but they must be generated by these expressions. When you decide that you have an infinite number of points, you cannot just make up 3 random numbers and call them a solution. They must be generated from these expressions.